Good afternoon, everyone. I think I'll get started. I'm Tanya Shastri, and I'm here today to speak a little bit about how one can use data, and especially big data sources, for customer support and just customer experience in general. And before I get into it, a little bit of background about myself. I've been plugged into the big data world for a while now. From the early days, doesn't seem like so long ago, though just 5 years ago, there were no such elaborate conferences. Unconference was the term used because just 5 years ago, it wasn't really clear what needed to even be talked about. People would, we got together to first decide what's going to be an interesting topic to discuss. So 5 years ago, I was at a startup that did NoSQL appliances. That seemed like very early in the day. And then since then, I've been at NetApp. I was in the CTO's office there and kicked off some of the big data strategy there. I was the big data lead at Google for a while. And then most recently co-founded a startup called Natero. And I'm not there anymore, but I think I was hoping one or two of my colleagues from there would be here. I don't see them yet, but if they are here, I'll point you to them when they arrive. In general, though, just the concept or the underlying thing under the presentation is twofold. One, of course, to kind of see how customer support and customer experience can be improved with data, but also to kind of put the thought process out there that it's been a while now. People should assume that tools are available to actually work with the data and to approach the problem kind of bite-sized and say, what are the answers you want to get from the data, and potentially partner with someone to take that first step. I was actually in a talk that was in this room just a couple of talks earlier, Metascale, where one of his closing comments was, don't wait to get things started and build things up. Go and start. You can always bring it in-house and develop everything yourself. But today there are enough tools available that it's fairly easy to get started. So this presentation really is twofold that way, and hopefully it gives you a sense as well of the kinds of things you can do. If you're logical and you have an idea, why not go and try it out and see what kind of an insight you can get from it. Here's how I've structured the presentation, and this is what you can expect from the flow. I'm giving you a little bit of context on what kind of a company are we talking about when we're discussing customer support. How do we get from the actual raw data to a business benefit? What are some of the methodologies involved? What are some of the metrics developed? And these could be different in different cases, but they could be fairly simple. And how do you go about just going from raw data to actually getting a business insight? We'll work through some sample analysis. I've separated out preparing the data because oftentimes preparing the data isn't really given the seat at the table it should deserve. It's often the part that's going to be the most complicated, and if you do that right, then suddenly the analysis can be really simple. So I've separated that out and given it a prominent seat at the table, so to speak, and then just wrapping up with a few considerations and learnings. And please feel free to just interrupt me whenever you like. Raise your hand if you have a question, and I'd love to do it that way, probably make it more interactive and interesting for all of us. All right. So here's a little bit of the context of the kind of company we're talking about. So we're talking about a company that's typically in the consumer space. So we're talking about either having a lot of users, a lot of end customers that actually leverage a product, or multiple devices. So for example, a consumer electronics company would be a good one to think of when we're walking through this. The one that this is actually based on is one that had millions of customers and many thousands of products. So it actually looked more like this, where there were many different products, and we were looking at it kind of in this way, right? There's many million users, many thousand products, and to kind of get a view of this across these two was pretty complicated even to begin with, right? And when you think about this, what we're discussing can be extended very simply to, the term being used just now, the Internet of Things, where there's any intelligent device. This could be extended all the way to any of those kinds of companies. So to take a quick look at the data sources, or what you might expect the data sources to be in these cases, prominently there's typically an incident database. And this incident database actually has all the incidents being an issue that somebody found with a product being filed in that incident database. And typically for customer support, that's been kind of the gold standard, right? Everyone uses that to figure out how many incidents have been filed, how are we performing, what's the rate of closure, so on and so forth, right? And in parallel with that, potentially some call center data where folks are actually responding to live calls for people asking for help. Oftentimes, there's a customer help website, places you can go to troubleshoot and so on. Oftentimes, there's information available over there, but the data from this site hasn't necessarily been used in understanding how to improve customer support. So we'll spend a little time on that and explore that a little bit. The third piece of data there is actually data from the actual device or the actual consumer appliance. Here, of course, the assumption is that it's intelligent, that it's able to send back some kind of data, whether it be some log event of someone taking an action, or actually the device itself sending back some call home data. So that's another area of data that's just beginning to be used sometimes on the product development side, but it could very effectively be used for customer support as well. So we'll just delve into that a little bit. And then finally, discussion forums and reviews and things like that where people have their comments. That's not necessarily as, it's a little more gray, right? You might get someone's sentiment and so on, and it's a little harder to really quantify it, but we'll just discuss it for completeness. Yeah, so all these words that are used with big data, disparate and structured and semi-structured and unstructured, transactional, logs, volume, velocity, variety. I'm sure you heard all these words said somewhere over the last 2 days. All of them can apply to these data sets. So for example, this was multiple geographies. The websites were in different languages and things like that. Data being collected in different geographies very disparately. The incident database itself was a very structured database, right? Actually an Oracle database with very structured rows and columns. The customer help website was much more semi-structured, kind of log, web logs and clickstream data was part of that. And then discussion forums and things like that are even unstructured, right? It's someone's comment in there which is free-form text. So when you look at it, it can look fairly complex, and you may want to put all this data into one place to begin with, and the task can look bigger than it actually needs to be. But if we kind of just take a view at this and make it a little more bite-sized, we'll go into a high level of the methodology and the metrics. So we'll discuss 3 different things. So first, tracking and improving self-help. So the concept here is that when you have millions of customers and you have many thousands of products, if you can help those customers help themselves, they're going to have less calls into your call center, and you're going to improve your customer support costs. Fairly straightforward. But how do you get people to help themselves, right? And not just that, are you sure that that improves the experience of the person who's on the other end? And actually it is from the standpoint of, at least from my personal experience, and I'll assume that it does extend to a bunch of you as well, it's much easier to go and kind of go to a website, find what the problem is, fix it yourself, versus pick up the call, wait for someone to answer, describe what the problem is, wait for them to respond to you, so on and so forth, right? So one of the key elements that we looked at was actually improving self-help through the support website. And it took integrating support website traffic, that's clickstream data, with the backend incident database. So 2 very diverse data sets, and we'll take a look at how that can be done. The in-product proactive support, that was actually taking a data set that hasn't really been used before, and it's quote-unquote big because it's many hundreds of thousands of devices spewing back data, kind of call home data, and just the volume of that data made it difficult to deal with. So kind of looking at those two cases, one kind of taking diverse data sets, one using a new set altogether. And then Finally, we'll talk about improving support efficiency. You can actually take some of these things and apply them to the actual support process. Someone answering a call, actually looking up what the problem was, interacting with a person, and figuring out where the inefficiencies are in that process itself. We'll focus on the first two more, though, and touch upon the third a little bit. All right. To tie this back to what we were talking about in terms of improving self-help, this is a really crude way of looking at it, right? The parameters here, we're looking at a score called score C, which is a crude score. How are we coming up with that score? We're saying we're taking the number of incidents that are filed for a particular product, let's say product P1, and let's say there are a few hundred incidents filed for that product. And then we take a look at how many page hits was seen on the product help page for that particular product. And we just divide those two. And the lower the score, the smaller that number, the better that page is performing, right? Because someone's able to go to that page and help themselves, and the number of incidents is lower. That's the intention behind this score anyway. Of course, you can find a lot of issues with this, right? Is someone going to that page to get self-help? Did they just land on that page when they searched for the product? Did they at all have an issue with the product and they went and spent some time on that page and bounced off? How do you know that that person was even interested in getting support? So you can poke a lot of holes in this, right? But at a high level, it is kind of taking that concept of saying that the less number of incidents indicated that that self-help page was able to help that end consumer in a better way. And then you can complicate this a little more. You can say, hey, I'm going to look at this in terms of sessions per user, because, hey, one user could have gone and back to that page 10 times to help themselves. Does that mean that I should count that 10 times? No, I should just count that one time, right? So actually, let me use this guy here. So here, for example, now you're looking at it per session, and per session meaning tracking a user across that user's actions on that website. And then we're also kind of looking at this here, this value here called RMAs, right? In the sense that if there was a hardware problem with the product, there was no way a self-help page would have been able to help anyway, so don't take that into consideration, right? Take that out of the picture, so you subtract that from the incidents, and then also you look at the number of sessions, and then you say, hey, if someone bounced off that page in under 10 seconds, maybe they came there and realized they really didn't want to be there. So that you can make this more evolved. I'm sure you can even find something more to do with this if you make this even more further elaborate if you wanted to. But this is a general sense of what you could do with just those two data sets, right? You're taking an incident database and you're taking your web clickstream data, and suddenly now you're able to tell how well your website is performing. So very quickly, this is a sample of some of that data, and it's a little normalized. You'll see the hits were divided by 1,000, score increased, just so that I could show it to you on one page. And here you can tell that, see, this score here is a bigger number than this score. And as we talked about before, a smaller number actually indicates that the product self-help page is performing better. So you can actually tell that product 2 seems to be doing better than product 1 in this crude. This is the crude one, all right? So we looked at it in a crude way. And so given this, it was the first step. So he said, hey, this first step, let's go and take a look at what this actually means. And when you think of thousands of products, doing this at that scale, we just organized everything like, in a decreasing score. So the top scores are actually the ones that are performing worst. So I went and I actually took a look at one of those web pages, and I said, is it going to be obvious why that page isn't working well? And interestingly, some of those pages didn't have a troubleshooting page at all. There was a blank page there, right? You go there and there is nothing. So some things were pretty evident, but when you have thousands of products, it's difficult to even keep track of something that simple. Is there a troubleshooting page there at all, right? So even at this crude level, there was something that came out of it, and we were able to kind of say that, hey, there are some pages that are performing better than others. And then to look at this, the more detailed score. So to think of this one and to just put these two in terms of the amount of effort required to calculate one versus the other. To calculate the 1, you were just counting up the hits to a page, pretty simple, and counting up the number of incidents, also pretty simple. The hard part was to really normalize across that, product 1 on a website's name is the same as product 1 in the incident database. And that's the kind of stuff that's really in the data prep part of it, which is more complicated. But from an analysis standpoint, that was pretty straightforward. For this one, it was much more complex, right? Each user, which was millions of users, are being tracked across the website. What were their actions? Did that user go to this particular product page and stuff like that, right? So it was much more involved. And then also more resource intensive. But really, the ratio of the scores turned out to be fairly similar, which was interesting. So the kinds of insights that one could derive were fairly similar from both of them. Of course, as you went more into detail, some of them were interchanged and so on. But at a course level, kind of low-hanging fruit, you could get low-hanging fruit from either approach. So the intention behind this being, start somewhere. If you can get your hands on the data, start analyzing it at a crude level if you have to. And B, the tools are available. And I haven't necessarily talked much about the tools because my mindset, and I hope yours too, is that, hey, the tools are available. It's for me to go out and find them or use the right tools. But if I have an idea, I should be able to play with these, beginning in a crude way and then, potentially doing something more involved, but not necessarily spending time on making it too perfect, because when it's big data, the answers are going to be relatively good in spite of doing something fairly simple. All right, so to move on to the next topic, and actually any questions there? Sorry, I didn't stop for questions before. All good? Yeah, sure. Oh, here, right? This one. I know. I should have helped you there with that. The RMA is a return merchandise authorization. This is a term used in support frequently where someone calls into a support center and they aren't able to help solve the problem because the problem isn't really in the software, or you can't really fix the problem, and they ask them to ship the hardware back. So that's a return merchandise authorization. And the reason for subtracting it away from the incidents was because you can't penalize a web page that's supposed to help someone help themselves when it's impossible for them to help themselves. If the problem is in the hardware, no matter how good that web page was, that person's not going to be able to help themselves with the information there. So that was the intention with removing the RMAs. Those kinds of pieces of information are actually quite interesting because, and things like this are available just in that, in the incidents database. How many of the incidents were filed and how many were RMA'd and things like that. And you can kind of get an idea by, using a ratio of these two whether some particular product has too many hardware issues. And that's much more on the product side now. So, I'm not going into that too much. Yeah, sure.
What do you measure whether somebody just stayed 10 seconds on it?
Right, so that. Correct. So see, that's for example, one of the ways of finding a hole in what's happening here, right? The expectation with big data is that, sure, there are probably going to be a few folks who do that, but is that going to be a significant percentage of the users who are on the web page? Then you might be able to use the mouse arrow, and if the mouse arrow is moving, it means you're actually on the page, but if it's not moving, maybe you went to another page. But hey, maybe there's someone who doesn't move their mouse when they're reading the page, right? So you can keep saying that there is still an issue with this, and you're probably right. This isn't 100%. But do you need to get to 100% to get the insight? Maybe not, And something as crude as that up there, which was surely far from 100%, already gave some insights, and you were already able to find something from a business standpoint to make improvements and reduce the cost, right? So that's the kind of the thought process behind this. Anyone else? No? All right, and so we were moving to the next one. Yeah, so we were moving to this topic here. And what we're talking about here is, I'm going to ask you to kind of take yourself away from the web, clickstream data and things like that. We're actually looking at only a single source of data here right now. And it may be unfair to call it a single source because this is coming from potentially from many devices, potentially from many hardware elements, potentially from many sensors. So they're coming from multiple devices, but they're all sending back kind of similar data, right? And the concept here is to be able to take that data and to be able to understand what a user is doing with the product, and then be able to kind of say, that looks strange, right? Or I wasn't expecting that to happen, or why did something happen? And be able to help a customer while they're actually using a product interactively and more proactively than actually waiting for them to call back. And you might have noticed this happening with some software products now where you might sometimes get a little prompt asking, is this what you want to do? Is this something that would help you, and so on, right? So that's that kind of a thought process where you're supporting a person while they're in the process of using a product. So in a sense, when you look at this, support becomes an integral part of product development, right? And thinking through how a person uses the product and improving their experience becomes part of the product development and the customer support. They become kind of joined at the hip. A lot of this analysis is driven by the behavior of that end user. What are they doing with the product, and what actions are they taking? And oftentimes, in this particular case, at least, we're talking about the analysis based on a sequence of actions, right? So an action 1 could be that someone turned on their device. An action 2 may be that they actually logged into a particular application. An action 3 may be that they interacted with it in some way. And here the simple approach is to just kind of figure out how many people are actually taking these actions. If a sequence of actions is actually expected, are you seeing the users actually going through each of these actions and not falling off? And also, how much time are they spending on each action? If they're spending a lot of time on that action, it's probably meaning that it's either a complicated piece of the product, and if it is complicated and it's intended to be complicated, well, it's intuitively acceptable. But if it isn't, then that time should be short. So in general, you'd expect the number of people reaching a particular step to be high and the time they take at that particular step to be fairly low. So here's an example of the sequence of actions, right? And I'll give you the actual use case behind this was a Bluetooth, a Bluetooth earpiece, for example. Think of that kind of a use case where you're trying to pair your Bluetooth device. And action 1 could be turning on the device. Action 2 to actually see it was a red light or a blue light or what have you, but the light actually burning steady. Action 3 was to press down on something and hold until the device said, pairing in process, right? Something like that. And action 4 was it actually got paired. With the data here, so you saw that this data is kind of indicating, hey, so most people got to action 1. After action 1, a large proportion of them got to action 2, action 2 being the light kind of burning bright. It seemed to people took very long to get from action 2 to action 3. Action 3 was to press down on that button. And then action 4 was the pairing to actually take place. Most intuitively when people had this problem, product management, customer support was intuitively saying, hey, they didn't have the other side. The phone wasn't close enough. It wasn't in the right mode, this, that, and the other. I'm sure it was a problem on their end. They didn't know what they were doing, right? But when you look at this data, it actually turned out that in the picture on the steps, if you have someone with a Bluetooth in their ear and they were kind of indicating that press something down on your ear, they had to, so step 2 was to look at the light burning red. Step 3 was to press it. It was most likely people trying to put something onto their ear, not being able to put it on in time, not pressing something in time, not doing it in time, and the product kind of timing out, right? And so a lot of the pairing not actually happening. Potentially in-house testing, people are very familiar with the device, being able to put it on fairly easily or doing it as it was expected to be done. So oftentimes data like this shows something which can be different from your intuition and brings out a potential area of where the problem may have been. Made sense so far? Yeah. How is the data being collected? Yes. That's right. So actually, the expectation here is the devices are intelligent. So in this case, the particular Bluetooth device, actually, you can actually have a session-based information actually being collected and actually being sent over either via the phone device or what have you, right? In general, something that's developing now and we're seeing more often is that it's kind of session-based data being aggregated on the endpoints. So you don't necessarily get just one little bit of data from multiple devices. And honestly, how is the data actually being collected? Two things. One, I'd assume that people who are looking at the data actually are able to collect their own data. That's one. And two, again, kind of going back to the philosophy that there are tools available, and if you actually looked for something, you would find it. You'd find actually one of two things. One, you'd find ready products that you could use, or two, you'd actually find boutique SIs who'd help you stitch together some of these things if you had to. A quick discussion around discussion forums and reviews. So there's been a lot of interest in collecting data from discussion forums, like things like Lithium and other things where people post comments. People are also able to post reviews to Amazon or other places, and actually aggregating that data and trying to understand what the sentiment of a person is one aspect. The frequency of a particular term. So if you look at this, again, kind of to go from crude to detailed, right? This is relatively crude. In a discussion forum, am I seeing this product being discussed more? Is the trend that it is, going up? That may already indicate a problem. Typically, people like to complain more than they like to say good things about something. So if they're on a discussion forum, I shouldn't say complain, but trying to solve a problem or trying to find a way to fix something they're working with. So a term frequency trend could indicate that a problem, support should expect that a problem will occur. And then sentiment analysis is, more refined, right? You're actually taking the data, doing some natural language processing and so on to try to estimate someone's sentiment. I don't know whether I have a great opinion on this personally. What do you do if the sentiment isn't great? What kind of exact business action you can take from it depends. So, I haven't spent too much time discussing that here. And then this last step here, actually, I should tie these all together to the intention was to discuss kind of improving the process, right? And the first piece there, a little bit of the term frequency trend can help a support team forecast that, hey, there's a problem coming with this particular product. Training staff, making sure that people are actually on site. An interesting one that came up just generally in this particular area was by tracking term frequency trends, you could tell that gaming devices were talked about much more on the weekend, and some other products, things like video cameras and stuff like that, were talked equally about on weekdays. Kind of leading to, you'd expect gaming devices, in hindsight, that people would be using them much more on the weekends. But video cameras, people are using much more video conferencing during work as well. So hey, that's an indication that maybe support staff should be beefed up for gaming devices a little more on the weekend, right? So things like that or insights like that are ones that you can get using this unstructured piece of the data. And yes, so this, I guess this is my pet peeve, if nothing else, is actually preparing the data, right? And we talked about, for example, the score and being able to take web clickstream data and analyze that in conjunction with an incident database. Those two data sets are really very different. The incident database, a standard SQL database, most people are relatively familiar with how to use it. You might find, a few folks able to work with your clickstream data, but actually joining those two together, analyzing them in conjunction, making sure that a product In this case, web clickstream data, you're typically going to have some marketing product names, and things are going to be the nomenclature and the hierarchies and things like that are going to be marketing oriented, versus something in an incident database is going to be much more SKU oriented, or much more product focused, internal operations focused nomenclature. And actually getting that to be normalized across both are pieces of the data prep, and kind of spending time on doing that well is pretty key for two reasons. One, that your analysis is actually accurate. Because if you're looking at product 1 here and product 2 there, then looking at those two numbers together is going to be completely meaningless. So doing that properly is pretty key. And then the second aspect of it, it's kind of the fourth bullet there, is at the outset, knowing that there's going to be different people who are interacting with that data. There's going to potentially be a product manager who wants to look at only one particular product versus a GM who wants to look at a product family. And having that product nomenclature all there up front, no matter who wants to look at it how, is probably the best way to do it initially. So potentially, you might have the information for the marketing product names. You might add in there the SKU-based product names. You might have the family names. You might have everything there. And one more aspect of big data to throw it in here is to give up some of that storage. You're adding a few rows. It's kind of like adding a few columns in a database. Sure, add them. It's much easier to add them, and then your analysis becomes much more simple. So in that sense, the data prep part of it has a lot of aspects of denormalizing the data, which is actually exploding that data out, making it bulkier, doing all the things that maybe folks, when you learned standard SQL principles, you were told not to do, is probably a good thing to do when it comes to big data, because actually doing that makes it so much easier to analyze the data after. The insights you get will probably be so much richer without the complexity. And reducing the complexity, the value of reducing the complexity is often, if not always, much more beneficial than trying to save on storage cost. The second bullet there, the enriching the events and logs with traditional data, if you think of it visually, I don't have a really good picturization of it, but if you think of web clickstream data, it's little bits of events. I often think of clickstream data as one of that not so interesting person who just keeps on telling you about everything they've done. I woke up, I brushed my teeth, I ate my breakfast, so on and so forth, right? So there's a lot of tiny bits of information, and oftentimes you've kind of tuned yourself out from it, thinking that there isn't very interesting information there. Unfortunately, some of these other big data streams have been bucketed under those categories in the past. But actually taking that data and enriching it with some back-end information. So for example, in this particular context, a device sending its stream of consciousness back, potentially having its device ID tagged on each of those little itty-bitty pieces of information, tied to a back-end system where that device ID is tied to the geography of that, of that device, to the, who purchased the device, where, their zip code, their income bracket, all that kind of information could be in a back-end database, and actually tying that to your device stream data. Now suddenly, that one little itty-bitty piece of information that someone actually used this particular feature, you're now able to kind of segment that on a very rich set of parameters, which was in a back-end database. So things like enriching events and logs with traditional data sets can be really very, can open up a very rich set of analysis, which may not have been available previously. Session-based analysis and session-based segmentation. So this was kind of to go back to the concept of tracking a particular user across their entire set of actions. Oftentimes, the end device can sessionize things very easily because there is just one user doing their stuff on that end, and then kind of sending that session stream back, and then being able to do session-based analysis is also very interesting. But from a preparation of data standpoint, actually enriching a session to back-end traditional data sets can also be interesting, because you might want to kind of segment or look at slice and dice various sessions by back-end parameters. And the last one I covered with the first, kind of just have that product hierarchy or drill downs. Anytime you think you might have various different people at various different levels of an organization wanting different slices of that data, just having that there up front is not really wasteful. Any questions there? All right. And yeah, so this is more or less me wrapping up. So while you're working with the data, I encourage you to start. I encourage you to kind of assume that the tools are available, assume that you will be able to get the technologists or the technical resources to be able to do it. But even in spite of that, expect it to be iterative, because oftentimes when you actually get a particular insight, you might find that some data sets were not properly instrumented. Sometimes there have to be corrections in the actual data because your analysis is only as good as your data is. Sometimes when you actually look at something, like we did the crude and then went into something more evolved, iterating that way, starting with something simple and then going deeper is a good approach. So expect it to be iterative. Data prep is a big deal. And I think doing good data prep means you're going to have some great analysis, and it's going to be very effortless once that data prep is done. With big data, simple analysis can be valuable. I think there's many companies that have actually been able to simplify their models. You don't really have to model anything if you're going to use all your data. So as you have bigger and bigger data sets and you're not sampling, your analysis can be simpler but still more valuable. And sometimes things might feel like, hindsight is 20/20, and you may think, hey, was it worth it to do all that? We should have thought of it before we actually did all the analysis. But actually doing the analysis makes you see it and is often worthwhile. And, hey, if you can see it, whether it's, after the fact or before, the fact that you've gotten a good business insight is justification to do some data analytics. So with that, I'll wrap up, and any last questions, I'm happy to take them. Over here? No, sorry. I would love to, though. I'm happy to chat with you about other things if you want to. Yes. That's right. Yeah, I think that my observation is that while they may not be throwing the data away, they're certainly not using it. And there's so many low-hanging fruit there. Just this customer support was actually a pretty low-hanging fruit, right? And absolutely, there's a lot of potential in it, and fairly simple, fairly low cost, potentially relatively high business benefit from it. All right. Thank you, folks.